In this video I'm going to go over some M1 Edexcel moments questions. The questions are actually quite recent international questions. The video has been made in December 2016. The first question is about a non-uniform rod. One of the first things I look for when I look at moments question is it uniform or non-uniform? It is helpful that they said it's non-uniform. We would have to assume it was so if it didn't say if it were uniform. It's given a reaction force I've just circled there. It's given the weight and the length of this thing. So let's just draw a quick diagram. It says it's been supported at P, where AP is 8, but the distance is the whole distance is 15. So AP being 8, that distance there is 8, and the whole distance there is 15. Okay, so we're also told that there's a man of 100 kilograms mass, or so 100 g weight, who is 2 meters from, let's make it slightly further over to make it more like 2 meters. So 100 g, who's 2 meters from A. We're also told that there's some other man who we're not told the weight of is 1 meter from B. Let's call it W. As I pointed out earlier, we're given the reaction force, which is 2009 newtons. Now 2009 is a bit of an odd number in a way. It's often occurs to me that it might be nicer to write that in terms of as a multiple of g along with the weights. So that would actually make that, if I divide by 9, 2009 divided by 9.8 is 205 g. Right, I haven't marked the weight on there yet. It may not be clear which side of the centre of mass the weight is. I'll put it there and adjust if it seems as though that might not be right. Let's put it there first of all, and we're told the mass is 25 g. Now, often in moments questions, resolving vertically is a good idea because we've got forces up equals forces down, which is normally easier than taking moments. The only force up is 205 g, the reaction force, and the forces down are 100 g plus 25 g plus W. So that gives me W equals 80 g. Okay, so W equals 80 g. Right, now looking at the distances, the distance from here to here is 6, and the distance from here to here is 6. So because 100 g is more than 80 g, I would expect the centre of mass to be as I've marked. Had this number come to something more, like 120 g, I'd be marking my centre of mass somewhere this side. But because it's less, I'm going to know it's that side. If you get it wrong, it's just going to come out negative in the answer. Now you might say, oh, I've marked X, but they want the distance from A. They want this distance. That's true, and you can mark X there if you want. I prefer to mark, because I'm going to take moments about P, so sometimes I'd rather call that X, but we do need to be careful that we add on the 8 afterwards at the end, because they're asking for the distance from A. So let's take moments about P. Right, looking at moments about P, we've got 3 forces only, and these both of these forces here are going clockwise. So let's work with those first. 80 g times 6. That's the moment of this force here. Plus 25 gx, which is that force there. Equals to 100 g times 6. which is the moment of that force there. Okay, now G cancels from everything, so it's always nice when G cancels. Okay, so G cancels from everything. That's 480, that's 25x, that's 600, so I get 25x equals 120, x equals 120 over 25, which is equal to 4.8 meters. So it's actually quite considerable way along here, further than I've marked. It doesn't matter, but what does matter is that we answer the final question. It wants the distance from A, so from A of centre of mass from A is at 4.8 plus the 8, which is 12.8 meters. Okay, so that's that question done. Let's go on to the second question. Okay, so as I say, this time we've got a uniform rod. First thing I tend to look for. It's 6 meters long, so let's put on the centre of mass of the rod, which is halfway along there. We're told the mass of it, so the weight is 4g. We have got a weight there of 2g. Okay, and there's another weight. It's actually a brick, but it's going to be a weight of 3g there. Now, the question, fairly standard thing, find the reactions at the supports RC and RD. Okay, now again, resolving vertically is a good equation to get. I could do it afterwards, but I'm going to do it now. RC plus RD is all of these masses added up together. So that's equal to 9g. Okay, now I can take moments about anywhere. I could take moments about there. It wouldn't be that sensible because I'll get a simultaneous equation in RC and RD, which is not something that we want to do if we've got an easier way. We can take moments about the supports. Well, if I take a moments about D, then RC only will come in the equation, whereas if I take moments about RC, RD will be the only unknown in the equation. So it doesn't really matter, but because we've been asked for the support at C first, I'm going to take moments about D. Okay, so let's look at the different moments we've got. We've got the two which are going clockwise, are the RC force and the 3G force there. Okay, so let's just look at those two forces first. Okay, and so this force here has got a moment. I'd probably better mark the distances on here actually. That distance is 1 because it's got that in the diagram. This distance is 2, that's in the other diagram as well. The centre of mass is 3 meters away, which makes that 1 and makes that 2. So we're going to take the moment, the clockwise moment of that force, which is RC, and it's 3 meters from D. Okay, plus the clockwise moment from that force, that's 3G times 1. And that equals to the two anti-clockwise moments. That one there, which is 2 meters away, so that's 4g times 2, plus this one here, which is equal to, that's actually 5 meters away, so that's 2g times 5. So that becomes 3rc plus 3g equals 8g plus 10g. So 3rc is equal to 15g. So rc is equal to 5g divided by 3. We can leave it like that. We don't have to work out what 5 times 9.8 is. But we're going to leave it like that, or write 49 newtons. It doesn't really matter. And then we know that they add up to 9G, so we can write that RD equals to 4G because they've got to add up to 9. Okay, so that's the part A done. Let's look at part B. Okay, part B says that the 3 kilogram is now removed and it's replaced with a force of a mass of X, so which would have a weight of xg downwards. It also says the reactions in the 2 planks are now equal. Okay, and we've still got the weight obviously in the middle, and the weight was 4G, and we still got this 2G mass here. Let's mark the distances in again, 2, 1, 2, 1. And it says find the value of X such that the 2 reactions are the same. So I'm going to resolve vertically again. We have 2R equals to 2G plus 4G plus XG. So 2R is equal to 6G plus XG. Okay, we'll store that up for later. Now, as far as a moments equation is going, it is often, you might be tempted to take moments about the pivot, which will be fine. You get simultaneous equation. And it's always almost a natural inclination to take moments about a pivot, but in fact moments are equal from any point. So I can take moments about B. It doesn't matter, it's not on a pivot. It's still, the forces which should be balanced around any point. So I can take moments about there. And why am I doing it by there? Well, because then X will not be in my equation. I'll get an expression for R, which I can directly put into there. Okay, so let's do that. Moments about B. I've got R times 1, because it's that force is 1 meters away. That's going clockwise. Then we've got this reaction force here, which is of the same value, but that's 3 meters away. So it's R times, 4 meters away. So it's R times 4. There's 4 there. Okay, so, and those are 2 clockwise ones. Then we've got the 2 anti-clockwise ones. So that's equal to 4G times 3. And then the other one, that's 6 meters away, 2G times 6. So that gives me 5R is equal to 12G plus 12G, so that's 24G. So R equals 24G over 5. So I can now substitute that R back into there. Okay, so I'm going to substitute for R, and I'm going to then get my value for X. So sub for R, I've got 2 times 24G over 5 equals to 6G plus XG. Okay, so the G cancels again, which is nice. I'm going to times through by 5 here, so I'm going to get 48 is equal to 30 plus 5x, which it gets me 5x is equal to 18. X equals 18 over 5, so x is equal to 3.6 kilograms, which is the answer. Okay, so that's the second question done. Let's have a look at the third question. Okay, so question 3 of these moments questions. we are talking again about a uniform rod, I think. It should say that somewhere. Uniform plank, it should say that somewhere. And yeah, uniform, always look for that, uniform. So we are told that the magnitude of the reaction at C is twice that of B. If I call the reaction at B R, then I can call the reaction at C 2R. It's uniform, so I'm going to have my weight, which is 6G, coming downwards. I've got a mass at the point X, and the load is 15G. Okay, and that looks about it. Now, I'm going to mark on some distances. 1.5 is that distance. Then we have 0.5 is this distance. And then we have the distance here that we don't know. That distance we don't know, so we don't know where this is. I can't mark off anything more at the moment. So, as I've said in the previous two questions, but in this case it's actually going to lead to an actual answer to part of a question. If we resolve vertically, it's always an easy equation to use. So 2R plus R is equal to 6G plus 15G. So 3R equals to 21G. So R equals to 7G, but do take care because it's wanted the reaction at plank C. So if you've done it that way, used R and 2R, then we need to double. So the reaction at C is 14G. Okay, so that's that part done. Right, now it's asking for, at this point it's asking for the distance from AX. Now again, what many people has marked this on as X, which is fine. I'm going to mark this distance as X and just add 1.5 to it, but it doesn't really matter. So B, if I take moments about C, it's going to all balance out. So I will have 0.5 times 6G for the moment of that force, which is clockwise, plus the moment of this force, which is X times 15G, okay, equals the moment of this force, but we did find that moment of 7G from before, so that's equal to 7G times 2.5, because the plank is 4 and it's 1.5 away from 4, so that's 2.5. Okay, once again, G falls out of the equation, and I can just multiply these things out. So I have 6 times 0.5 is 3, and I have 15x is equal to 7 times 2.5, which is 17.5. So x is equal to 14.5 over 15, or 29 over 15. But we want to add 1.5 to that. So the distance, because that's the disadvantage of setting up like this is that you must remember to add up. Otherwise, just mark the unknown you want on the diagram. So 29 over 15 plus 1.5. Okay. Divide 15 plus 1.5. Oh, it's not over 15, of course, it's 29 over 30. Okay. So that's 29 over 30 plus 1.5. 37 over 15. So that's that part of the question done, and then we've got a fairly standard tilting situation in the next part, so let's go on to that. So now let's move on to part C. Okay. This time it says the load is now moved to a point Y between A and C. So we move this now somewhere here, say. Okay, the mass of this is 15g, and we've still got the 6g, which is 0.5 from here. Now the key to this situation here is, yes, there will still be a reaction force here, but no, there's no reaction here because it's tilted about C. So we can just take moments about C, so it's fairly easy, 3 marks. I'm going to mark this distance as x. So I have 15g times x is equal to 0.5g, 0.6g times 0.5. Okay, once again, seems to be happening in all these questions, it often does, the g cancels. So we have, that's x is equal to 3/15, which is 1/5. However, or 0.2. However, we want it from A, we want the distance AY, so that means AY is equal to 1.5 minus 0.2, which is 1.3. I'm seeing most people write in the equation, which is what it does on the mark scheme as well, which is fine. Anyway, there we go. That's question 3. Nothing too stretching there. See what question 4 has in store. Okay, question 4. Perhaps the wording of this question makes it slightly more difficult, particularly in part B. It doesn't talk about toppling, but that's it for part A either, but it is basically that. So they've changed the wording of it a little bit. We've got a rod AC and it's supported at one point A at the end, and they've marked the other end C, and it's also supported at B, where this is L and this is 2L. It's uniform, so we look for the uniform rod. Hopefully that's right at the beginning. So it's uniform of weight W. Okay, a particle of weight 2W is placed on A, supported at A. So we've got something that's being placed along the support here, along here. Now, when it talks about the greatest possible value, well, clearly it could go anywhere along here, but once we start going along B, there's always a chance that it's going to start toppling. So that's what it must be referring to here. So for this part, let's just place it over here, and it's the weight 2W. Now we're going to have a reaction force here, but it's greatest, so at the greatest distance from A, it's going to be at point of toppling. So in other words, if we to go any further, it's going to actually topple around B. At B. So the key here is reaction here equals 0. Like it was in the last question. So I'm going to mark X on here and then decide what the final distance is there, because that's X. And we know that because the whole rod is 3L, and this is 2L, that this must be L over 2, this distance here. Okay, let's put that. So let's take moments about B. So there's no reaction force, there's only two forces there. So we've got W times L over 2 equals to 2W times by X. Yes, it's that force and that force having the opposite moment turning effect around B. Okay, so that means W is going to cancel. Okay, and so that gives me X equals L over 4. But we want the distance AX, the greatest possible value of X, or I've probably, it is a bit unfortunate that I've marked it as X here. Probably shouldn't have done that because it actually specifically called this distance X in the question. Okay, let's just change the letter just to get it consistent. Let's call it Y. So X is equal to Y plus, and this distance all the way along is equal to the distance all the way along from here is equal to 2L. So it's equal to Y plus 2L. So that's 9L over 4. Okay. So that's that question done. Question A. Okay. Right, B. Slightly different situation. It's now talks about the least possible value. Okay, let's draw the diagram again. Support at B. Now we've got the weight W. Now 2W is going to go somewhere else along the rod here, but the key is it says due to a weakness at A, we can't go too close to this point here, because if we go right on this support here, we'll find that we're at its maximum value for the reaction there, and it's obviously that's going to be more than it can handle. So at the extreme time, when this is as close as it can be, let's make it over there, 2W over there, and we can't go any closer because as we move, oh dear, struggling to draw the forces here, there you go. Because as we move closer, as we move along here, obviously it can't go too far here, so in part A, because it's going to topple, but as we move further along the rod, the reaction at B here is going to decrease as we move further on, and it's going to be its maximum value here, but it's saying that it can't handle a certain reaction force there. So X will be at its least possible value. In other words, we'll be at closest we can possibly be at A when the force here is 2W and the force here is equal to W, because forces up must be equal to forces down. Yeah, so that we need them to be balanced. We've got 3W going downwards, so then we need 3W going upwards. That simple principle. Forces up making equal forces down comes in very handy again. So I'm going to take moments about here, and that should come out quite nicely then. So we have moments about the support A. We have 2W times X, and we've got that's going clockwise. We've also got this force here, which is because it's halfway along the rod, L over 2, so that's plus W times L, 3L over 2, because it's 3L long. And then the moment, is it going to be equal to the moment of this force here? Now that distance from there to there is 2L. So we can just say that equals to W times 2L. Right, now W cancels. Okay, so we have 2x plus, oh, let's take the other to the other side, is equal to 2L minus 3L over 2, which is equal to 4L minus 3 over 2L, so that equals to L over 2. So x equals L over 4, which is the final answer. Let's write it here to keep it separate. X equals L over 4. So that is that. That's that question done as well. So not 10 very quick marks. Think about it. It's not a lot. I wrote this, which was just to explain. So you wouldn't have to write that in the exam. So there really wasn't much to actually do if you set up the equations nicely. Okay, so that's question 4. The wording a little bit problematic, but that's fine. Interpreting question. I'd say that's the challenging part of that question, was the wording and interpreting what they're looking for. Okay, question 5. Last question of this series of questions here. Oh, it looks pretty standard again, I think. Okay. Okay, so this is a non-uniform rod, but it's not an unknown centre of mass. It's actually a given centre of mass, which is 2.2 meters long. So it's really not an issue at all, just so long as we don't put it in the middle. So it's a given weights here. So please, no G's now, because we're given weights. Okay. So 120 newtons is the weight of the thing placed at G. It says a particle of mass 40 newtons is placed somewhere along it, or at some point P. It's arbitrary where I put it because it hasn't told us anything. Clearly, wherever I put it, there's going to need to be a tension in A and B. So it's arbitrary where I put that thing. It'll just affect A and B where I put it. So I'm going to put it there. So that's X, and the particle is of mass 40 newtons. Okay, so I'm going to resolve vertically because it's just so easy to do. It's the easiest marks to gain. So 2A plus TB is equal to 40 plus 120. So TA plus TB is equal to 160. Okay, so we've got that. Obviously that's not going to help us yet to work out these. Now it does say the key thing is here, it's asking for the things in terms of X. So it has told us that, because too many unknowns here, unless we know where X is, we're not going to know where TA and TB are. Okay, so let's take moments. Okay, since I've called it X there, let's take moments about A, which is the most obvious one, because then it's going to be a nice easy equation. Both of these forces have got a clockwise moment. So let's just pick this one. That's 40 times by X. Keep saying no G's here. This is 2.2. So just so long as you didn't read it, it was uniform. It's 120 times 2.2. And then this is the anti-clockwise one. The thing's 4 meters long. So that's TB times 4. Okay, if I divide everything by 4, I get TB is equal to 10x plus 30 times 2.2. So TB is equal to 10x plus 66. Right, so this is going to be quite nice because that's the answer to A part 1, by the way. A part 1, you can call that. part 2, we can just use that TA plus TB equals 160. So we get TA plus TB, so that's 10x plus 66 equals 160. So taking those over to the other side, it's TA is equal to 94 minus 10x. I have just noticed whilst I was writing this that I've got my answers to part 1 and 2 the other way around. It doesn't matter. Okay, it really doesn't matter that I've written it the wrong way around. So that's 2A, 1 and 2 for the whole bit. That's fine. Right, so you could, if you really want to be, that's part A1 and this is part A2, just in case but the examiner will be perfectly capable of figuring that out. Then part B says either string will break, so we're just going to have it will break if it exceeds 84 newtons. So that means that these tensors need to be less than or equal to 84 newtons. So we can say TA and TB. TA has got to be less than or equal to 84, and TB has got to be less than or equal to 84. So let's just do the TA bit first. 94 minus 10x has got to be less than or equal to 84. So that gives me 10 is less than or equal to 10x. So x is greater than or equal to 1. Just swapping inequality around a bit. And then this one, we've got TB is less than or equal to 84. So we have 10x plus 66 is less than or equal to 84. So then we have 10x is less than or equal to 84 minus 66, which is 18. So x is less than or equal to 1.8. So let's write it as 1, because it wants a range, so I think they might want 1. I haven't looked to the mark scheme to be honest, but I would expect they probably wanted it written as 1 range. So x is going to be greater than or equal to 1 from that, and less than or equal to 1.8. That's the final answer. Okay, so that's 5 questions. I think what might be noticeable is that if you pick the right equations and it's taken 38 minutes to do, I think the total marks for the thing is 50. So we've easily gone in time, and I've waffled on a bit as well. It's just choosing the right equations and just interpreting the questions, and then we're done. Okay, so that's it. Hope you enjoyed it. Bye.